Okay, water. Water has a molecular formula of H2O because it has two hydrogen atoms bonded to one oxygen atom. The bonds are covalent. You can see down here in the diagram that oxygen and hydrogen share a pair of electrons between each of them. And the atoms then stick together in covalent bond. Oxygen has a greater attraction to electrons and holds the shared atoms closer. Therefore, it has a slightly negative charge and leaving the hydrogens with a slightly positive charge. So this type of bond is called a polar covalent bond because of the unequal sharing of those electrons. In addition, in the entire water molecule, there's an uneven distribution of charge, and therefore you get a bent shape. And so you have a slightly positive end and a slightly negative end of the molecule. The hydrogens have a slightly positive charge and the oxygens have a slightly negative charge. So when you have two water molecules near each other, they are actually attracted to each other because the positive hydrogen atoms are attracted to the negative oxygen atoms, and this causes the water molecules to stick together. The vocabulary word associated with this phenomenon is called cohesion. So think of co meaning together. So cohesion is when two water molecules stick together. And this kind of bond that is an attraction really between two atoms that are involved in additional other bonds is called a hydrogen bond. So in this diagram, there are actually two kinds of bonds being shown. You have the polar covalent bond between the hydrogen and oxygen within the water molecule, and the hydrogen bond between the hydrogen and the oxygen of two different water molecules. So water is sticky, and cohesion is the idea that water sticks to water. You are going to be required to be able to identify these two different bonds for tests and quizzes. So make sure you study them. You might want to make flashcards with those pictures if you have not had chemistry already. So what are the implications of cohesion? Well, cohesion actually creates surface tension. So water molecules are attracted to each other by hydrogen bonding, as I said, and it creates a film at the surface of water, and it actually allows certain insects to actually float on the surface of water, even though they're denser than water and should sink because typically solids are denser than liquids, and a solid that is denser than the liquid that it's in will sink. However, in this case, the water strider is actually denser but won't sink because of the surface tension caused by the cohesion of water. And in fact, that's actually how detergents and soaps work to clean your clothing. It actually breaks the surface tension of water and allows water to get into the fabric more easily. So really the purpose of soap is to help water do its job better. So some other implications of the polarity of water and therefore the hydrogen bonding is that hydrogen bonds have to absorb heat to break and release heat to form. And so this means that oceans and lakes can act as heat sinks, and they absorb heat in the day and release it at night, and it keeps temperature changes within a suitable range for living things. It's due to the high specific heat of water. If you've had chemistry, you will remember that you learned that the specific heat of a substance is the amount of heat per unit mass required to raise the temperature by 1 degree Celsius. So water can actually absorb a lot of heat before it changes temperature. So you get milder climates in coastal areas, and you get ocean temperatures that don't change as much as the air around them. So this makes them suitable for aquatic life. You may be aware or may not be aware that if you are in a desert, it gets very hot during the day, but also fairly cold at night. So there's a big temperature range in a desert ecosystem because there's no water around. So generally, like even if you're at the beach, not that far away from here, like as we live in Maryland, if you go to the beach, it's usually a little bit cooler in the summer and a little bit warmer in the temperature right by those coastal areas. So adhesion is actually the idea that water doesn't just stick to water, it sticks to other substances. So adhesion is the attraction of water to other substances due to its polarity. This makes it an excellent solvent. It's often referred to as the universal solvent, although it doesn't dissolve everything. It does not dissolve lipids typically, but it is a very excellent solvent. It will dissolve anything that is polar or any bond that is, any substance that's formed by ionic bonds typically. Table salt is one example of something, of an ionic compound that water can dissolve fairly easily. So another implication of adhesion is called capillary action. Because water molecules are attracted to glass, and more so than each other, water will actually rise up in tall, thin glass tubes. So if you've ever had blood drawn, they often use little capillary tubes to take samples of blood, because most blood is water. It has other things dissolved in it, but there's quite a bit of water in it. So glass, you may be aware of, is made of sand, and no matter how hard we try, we can't get all the salt out. So when we make glass, there are some charged particles in that glass, and so that's why water is actually attracted to the glass. In living things, particularly in plants, this actually happens in the xylem, which is the water-conducting tissue in plant stems. The xylem is also attracted to water, so you get the capillary action. So water will rise up against gravity in very tall trees because of the adhesion of the water to the sides of these thin, empty tubes of cells, and because of the cohesion of water. Because when water evaporates, it pulls other water molecules with it, because remember, water sticks to water. So once the water evaporates, it pulls other water molecules with it, and because those long tubes of xylem are so skinny, and because water is attracted to xylem, water will actually kind of climb up the xylem as long as you have evaporation from the leaves. Another interesting property of water is that ice, which is the solid form of water, is less dense than liquid water. This is fairly unusual. Typically, substances are denser in their solid form. But if you look at this diagram, you can see that we have solid ice, and then we have liquid water, and we have water vapor in its gas form, so solid, liquid, gas. So actually, when ice freezes, it expands. So you can see here that the water molecules are further apart in the solid form than they are in the liquid form. You may have noticed this if you've ever bought a bottle of water and put it in the freezer because you wanted it to get cold more quickly, and then you forget that it's there, and when you come back, it will be bulging. Sometimes if you do it with a glass soda bottle, it will actually explode in your freezer. And that's actually why when they build bridges, they often put like metal teeth in the middle that are kind of like this, so that when the bridge freezes, it can expand and contract, and with those temperature changes. So typically an object will only float in the liquid if the object is less dense than the liquid. And so ice will actually float in your glass of water. So a biological implication of water expanding when it freezes is actually frostbite. So frostbite is caused when the water in cells freeze and expand, and they cause cells to rupture. And typically this happens in the extremities, like your fingertips and toes, and sometimes the tip of your nose. Because when you're in a really cold environment, your capillaries actually contract and really bring the blood to the core of your body to keep your body temperature from dropping dramatically, but sometimes at the expense of a finger or a toe.